Assalamualaikum and very good morning to all of you, especially to lecturer Professor Madya Dr. Muhammad Shukri bin Mustafa and fellow students. Today we are from Group 4 going to make a short presentation about our group project titled Deflection of Beam. So now I will start with introduction first. As you guys can see here, what is a beam actually? So, for your information, a beam is a structural element that bends when forces or loads are applied to it. This is an important topic in engineering because it helps us understand how structures like bridge and building behave under pressure. Knowing how beam deflect ensure they are safe, strong and work as expected. Understanding deflection is crucial because too much bending can make structure unsafe or fail. By studying how beams react to different forces, engineers can design structures that are both efficient and reliable, using materials wisely and improving performance. This experiment aims to study how beam bends when forces are applied. It also compares the actual bending result with the projection made using formulas like Macaulay method. This helps us learn more about the relationship between force, bending and safety in structures. Next, the main objective of our group project are first to learn how a beam bends under different loads. Second, to study the forces and bending moments inside a beam caused by this load. Third, to calculate beam deflection using simple mathematical method like Macaulay methods. And the last one is to understand the connection between the weight applied to a beam and how much it bends.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aminul Naim Bikam Afendi. My numeric number CD23002. I want to present about experiment design and apparatus. First, load hanger and weight. The weight must be 10 Newton. Second, steel bar. The dimension is 1 meter long. Third, deal gauge. The sensitivity of the deal gauge must be at least 0.01 millimeter. Fourth, vernier caliper to measure the beam's dimension. Fifth, support feature. Adjust support to create simply support.
My name is Muhammad Siraj Faki bin Saifuddin. My material number is CD230180. So now we'll talk about a test material, which is steel bar, low dead gauge, hanger weight, and the last one is vernier clipper. So for our group use steel bar, a long steel bar with a length of 1 mm, wide of 32 mm, and a height of 6 mm. So the material has a Young modulus of elasticity which is E, 200 JPa, and I, which is a moment of inertia, is 5.3136. I'm sorry, 3139 power of 10. So now for the load. Alright, the load was cylindrical steel weight with 10 Newton increment up to 50 Newton. So the external force required to test the deflection of the beam under various circumstances was applied by this weight. Next, we go to the dial gauge. Alright, the deflection of the steel bar was precisely measured using a precision measurement tool with a 0.01 mm scale. And next, hanger weight. Alright, this part made it easier to attach the steel weight to the test specimen, and was used to hang the load at the design location along of the beam. And the last one is vernier clipper. So the vernier clipper, to ensure accurate computation of parameter like the moment of inertia, the steel bars wide and height were measured with high precision using a digital vernier clipper or a normal vernier clipper. Next, we go to the procedure. Okay, first, clean the surface to the beam to ensure proper adhesion of the straight gauge. And then the thickness and the width of the steel bar is measured by the vernier clipper. And then adjust the position of two lower anvils to the end of 95 cm. Next, the beam is put on the two lower anvils and measure the starting point to the place applied load is 50 cm. Next, the load hanger is hung 50 cm from the straight point. And 6, set the reading dial gauge to 0 to avoid the error. 7, the load 10 Newton is applied at the load hanger. And the 8, record the reading from the dial gauge. And the last one is repeat step 6 to 7 by adding 10 to load hanger until 50.
Next, I'd like to present about the data presentation. From the figure that shown, E equal to Young modulus of steel, B width, D height, L length of steel bar, O is initial deflection of steel bar, I is moment of inertia of steel bar. This document presents the result of an experiment analyzing the deflection of the steel bar under the different loads. The experimental and the theoretical deflections are compared, and the presentation difference is calculated. For the test 1, the percentage difference is 3.57. For test 2, the presentation difference is 30.06. For the test 3, the presentation difference is 3.77. For test 4, the presentation difference is 7.74. For test 5, the presentation difference is 15.24.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus bin Binandis. My matric number CD23009. So for the calculation, we use two formula to find the load. First formula is Y max equal to PL power 3 over 48 EI to find the theoretical load, and percentage equal to theoretical minus experimental over theoretical times 100% to find the percentage. And this project we use only 5 load, which is 10 Newton, 20 Newton, 30 Newton, 40 Newton and 50 Newton. So for the load 10 Newton, the Ymax is 1.6807 meter. 20 Newton, the Ymax is 3.3614. 30 Newton, Ymax is 5.042 meter. 40 Newton, 6.7227 meter. And last is 50 Newton, is 8.4034 meter. So for the percentage difference, we get the 10 Newton is 3.57%. For load 20 Newton, 30.06%. For 30 Newton, 3.77%. For 4 Newton, we get 7.74%. And the last is percentage for 50 Newton is 15.24%. This is for the calculation to find the Ymax and percentage difference. Thank you.
Hello, my name is Shazmi Binti Azhari. I will cover about conclusion and recommendation. This project aims to understand the elastic curve and its deflection diagram. Students learn to sketch and locate the maximum point on the curve, establish the deflection range, and determine fixed end beam deflection. The experiment showed the beam deflection behavior is influenced by parameters like the modulus of elasticity and geometric parameters like specimen length and thickness. The experiment demonstrates how theoretical calculation can be applied in hands-on testing, making abstract concept more practical. However, the experiment faced issues with the setup such as bending with minimal weight. Precision and accuracy are important in scientific research. Regular calibration and maintenance of equipment ensure accurate reading and the appropriate tool range. Recording measurement with significant figure help maintain precision. Averaging and minimizing random mistake reduce measurement error. Measurement System Analysis (MSA) simplify assessing instrument and result accuracy, ensuring reliable data and test result. That's all from us. Thank you.